across the unfathomable darkness that separates the stars, an emptiness so profound it defies human comprehension, drifters move in silence. They are relics of creation born in the swirling dust clouds that birthed suns and worlds in galaxies far from our own. For eons they wander the interstellar void, exiled from their stellar nurseries' travelling paths, dictated by gravitational whispers from stars they will never approach. Most will journey for eternity, their lonely pilgrimage, unseen, unknown. But every now and then, by a celestial alignment so improbable, it borders on the miraculous, one of these silent voyagers crosses our path. It falls into the gravitational basin of our sun, a fleeting guest from an alien shore carrying with it the secrets of its distant origin. For centuries we believed our solar system was an island universe hermetically sealed from the galactic ocean. Our comets were our own, born in the cold periphery of our sun's influence. They were familiar, if sometimes startling, members of our celestial family. Then everything changed. And the man who changed it was not in a state-of-the-art facility surrounded by gleaming machinery and government funding. He was in a small, self-built observatory in Crimea, a lone sentinel under a canopy of familiar constellations. His name is Gennadiy Borisov. An amateur astronomer, a telescope engineer, a sky watcher driven by a pure and relentless passion for the cosmos. He is a hunter of comets, a modern-day celestial tracker sifting through the star-dusted blackness for faint smudges of light, the ghostly apparitions of ice and rock awakening from a deep slumber as they near the warmth of our star. In 2019, he etched his name into the annals of astronomy when he spotted a traveler of truly extraordinary pedigree. An object moving too fast, its trajectory a defiant slash across the sky that could not be contained by our sun's gravity. It was designated 2I, Borisov, the second known interstellar object and the first to bear the name of its discoverer, a true comet from another star. Now, from that same lonely outpost, Borisov has done it again. Or he has flagged another whisper in the dark, an entity catalogued as GB00810. It is an object of profound ambiguity, a ghost on the edge of perception, teetering on the very knife's edge of definition. Its trajectory is strange, its nature unknown. Is this a faint, unremarkable piece of debris from our own backyard? A chunk of ice from the farthest reaches of our own solar system? Or is it something more? Is GB00810 another messenger from the interstellar deep, a cryptic postcard from a world we can only imagine? Is it a faint comet or an interstellar impostor? To comprehend the magnitude of this question, we must first journey back to a time when comets were not objects of science but omens of terror and upheaval. To the ancient mind, the heavens were a clockwork of divine perfection. The sun, the moon, the planets, they all moved with a comforting, predictable rhythm. They were eternal, unchanging. Then, without warning, a spectre would appear in the night sky, a luminous head with a long, ethereal tail, a celestial sword hanging over the world. These apparitions were seen as breaches in the cosmic order, harbingers of plague, the fall of kings, the ruin of empires. They were divine messages, and the news was never good. This perception of comets as atmospheric disturbances, as phenomena of the air rather than of space, held sway for millennia. It took the meticulous eye of a Danish nobleman in the 16th century to begin to unravel their true nature. Tycho Brahe, an astronomer of unparalleled observational skill, tracked the great comet of 1577 with painstaking precision. By comparing his measurements with those of other astronomers across Europe, he used the principle of parallax, the apparent shift in an object's position when viewed from different locations. He discovered the comet exhibited almost no parallax at all. This meant it had to be far, far more distant than the Moon. It was not an atmospheric event. It was a truly celestial body, a wanderer among the planets. The heavens were not unchanging after all. A century later, the brilliant mind of Edmond Halley would tame them further. Studying the historical records of cometary sightings, he noticed a striking similarity in the orbits of comets that had appeared in 15311607 and his own observation in 1682. Applying the newly formulated laws of universal gravitation from his friend Isaac Newton, Halley made a prediction of breathtaking audacity. He proposed that these were not three separate comets, but a single object locked in a vast elliptical orbit around the Sunday. He proclaimed it would return again in late 1758. Halley did not live to see his prediction fulfilled, but on Christmas night of that year, a German farmer and amateur astronomer spotted the returning Voyager. For the first time, a comet was no longer a random omen, but a predictable physical member of our solar system. It was named forevermore Comet Halley. This revelation opened a new chapter in our understanding. If comets were part of our solar system, where did they originate? The answer lay in two vast, unseen realms at the cold, dark edge of our Sun's kingdom. The first is a scattered disk of icy bodies beyond the orbit of Neptune known as the Kuiper Belt, the birthplace of short-period comets like Halley's. But for the long-period comets, those with orbits stretching thousands of years, we needed a far grander reservoir. In the 1,950 seconds, Dutch astronomer Jan Oort theorized its existence. A colossal spherical shell of trillions of frozen relics from the solar system's formation, encircling our Sun at a distance of nearly a light year. This is the Oort Cloud. Imagine our solar system with its planets and asteroids as a single bustling city center. The Kuiper Belt is the sprawling suburban district surrounding it. But the Oort Cloud is the vast untamed wilderness that extends for thousands upon thousands of miles in every direction. It is an immense dark sphere of profound emptiness, sparsely populated by icy wanderers in a state of deep cosmic hibernation. Occasionally, the gravitational nudge of a passing star or the tidal forces of the Milky Way galaxy itself disturbs one of these sleeping giants. It is dislodged from its eons-long orbit and begins a slow, inexorable fall inward toward the distant beckoning light of the Sunday. After a journey of millions of years, it finally arrives blazing across our skies as a long-period comet, a visitor from the most remote province of our own solar domain. For all of history, we believed this was the complete story. All comets, all visitors were our own. They were born here and they would die here. The idea of an object arriving from another star system seemed like pure fantasy. The distances are simply too immense, the odds too long. It was a theoretical possibility, but one no one ever truly expected to witness. Then, on October 19, 2017, the Pan-STARRS telescope in Hawaii detected something extraordinary. An object initially thought to be a comet was moving in a way that defied celestial mechanics as we knew them. To understand its strangeness, picture the Sun's gravity as a vast, gentle basin carved into the fabric of space-time. Objects belonging to our solar system, like planets and comets, are like marbles rolling inside this basin. Their paths are closed curves, circles, or ellipses. Even a long-period comet from the Oort Cloud arriving on a very stretched-out path is still bound by the basin's edge. It will eventually turn around and head back out. Its path is gravitationally bound. This new object, however, was not rolling inside the basin. It was a bullet fired from somewhere far away that was merely streaking through the depression before continuing on its way. Its trajectory was not an ellipse but a hyperbola, an open curve. It was moving with such tremendous velocity that the sun's gravity could only bend its path, never capture it. This was the smoking gun. This was undeniable proof. The object was not from here. It was an interstellar visitor. Scientists scrambled every available telescope to get a look at this fleeting guest, which was designated 1I, ʻOumuamua, a Hawaiian name meaning scout or first distant messenger, and the more they looked, the stranger it became. It was small, no more than a few hundred meters long. It was reddish in color, likely irradiated by cosmic rays over its long journey. Most bafflingly, it showed no cometary activity. There was no coma, no tail of gas and dust. It appeared to be a dry, inert piece of rock or metal. Yet as it sped away from the sun, astronomers detected a slight but unmistakable acceleration. It was being pushed by some unseen force, a non-gravitational nudge. For a normal comet, this is easily explained by the outgassing of sublimating ices acting like tiny rocket thrusters. But ʻOumuamua had no visible outgassing. This conundrum ignited a firestorm of debate. What was this thing? Theories ranged from the exotic to the extraordinary. Perhaps it was a new type of object we'd never considered, like a nitrogen iceberg, a fragment chipped off a Pluto-like planet from another solar system whose outgassing would be invisible to our telescopes. Maybe it was an incredibly porous, fluffy object, a cosmic dust bunny pushed by the gentle pressure of sunlight itself. Or as proposed by Harvard astronomer Avi Loeb, perhaps it was something else entirely. He argued that its unique combination of features, the peculiar shape inferred from its light curve, the lack of a coma, the mysterious acceleration, pointed to the possibility of an artificial origin, a piece of alien technology, a solar sail tumbling through our solar system. The suggestion was met with immense skepticism, but it highlighted just how profoundly weird our first interstellar guest truly was. Oumuamua was a cosmic enigma. It gave us a tantalizing glimpse, then vanished back into the interstellar night, leaving us with more questions than answers. It was a messenger that had delivered a sealed letter. Then less than 2 years later, Gennadiy Borisov from his perch in Crimea spotted the second one. And this visitor, 2I, Borisov, was completely different. As soon as it was identified, it was clear this was no ʻOumuamua. It was fuzzy. It had a distinct coma and a broad dusty tail. It looked, for all intents and purposes, exactly like a classic comet. Here was a sense of profound relief in the astronomical community. Oumuamua was the bizarre outlier. 2I, Borisov, was what we expected an interstellar comet should be. It was a dirty snowball, just like our own. But a closer look revealed it was a familiar stranger with a distinct accent. By using a technique called spectroscopy, astronomers could analyze the light passing through its coma, breaking it down into a rainbow of constituent elements. This is the chemical fingerprint of a celestial body. It tells us what it is made of. The analysis of 2I, Borisov's fingerprint, yielded a stunning surprise. It contained an unusually high concentration of carbon monoxide, far more than any comet ever observed from our own solar system. Carbon monoxide ice only forms in extremely cold environments, colder than the region where our own solar system was born. This single chemical clue was a revelation. It told us that 2I, Borisov, likely formed in the frigid outer disk of a red dwarf star system, a much smaller and colder star than our Sun. For the first time, we held in our hands, or rather in our light detectors, a physical sample from a completely different planetary system. We were doing geology of another star's domain from hundreds of light years away. 2I, Borisov, proved that the building blocks of planets elsewhere were similar to our own, yet subtly, fascinatingly different. This is the legacy that precedes the newest puzzle. We have encountered 2 interstellar travelers. One was a profound mystery, a bizarre rocky needle in the cosmic haystack. The other was a more familiar icy snowball, but with a strange chemical dialect. And now from the same observer who found the second comes a third potential candidate, the faint ephemeral smudge known as GB00810. The initial calculations of its orbit plotted from Borisov's first few observations are tantalizing. The number that astronomers look for is called eccentricity. An eccentricity of 0 is a perfect circle. Between 0 and 1 is a bound elliptical orbit. An eccentricity of exactly 1 is a parabolic orbit, the escape velocity from the sunday. Anything greater than 1 is a hyperbola, an interstellar trajectory. The initial orbit for GB00810 showed an eccentricity of around 1.1, a number that puts it firmly in the interstellar camp. But this is where the mystery deepens, where the case divides. The argument against its interstellar nature is grounded in caution and probability. Occam's razor, the simplest explanation, is often the correct one. And the simplest explanation is that GB00810 is a native of our solar system. The object is extraordinarily faint. This makes precise measurements of its position incredibly difficult. Think of trying to determine the exact speed and direction of a distant car by looking at a single blurry photograph taken at night. You might get a general idea, but your margin for error would be huge. Every new observation, every new data point refines the orbital calculation. It's like adding more photographs taken from different angles over time. The initial hyperbolic orbit might just be an illusion, a phantom created by these large initial uncertainties. Many newly discovered comets from the Oort Cloud initially appear to have slightly hyperbolic orbits, simply because we are seeing a tiny sliver of a vast, almost straight-line path as it approaches the sunday. As we track it for longer, the eccentricity value often drops, settling just below 1, revealing its true bound nature. It's a celestial case of mistaken identity that happens all the time. Furthermore, its dimness could simply mean it is very small, or that its surface is very dark and non-reflective, covered in cosmic dust. It could be an old spent comet, one that has made many passes through the inner solar system and has exhausted most of its volatile ices, leaving behind a dark carbonaceous crust. It is a ghost of a comet, a barely there whisper that is simply hard to pin down. The cautious scientific mind must assume it is one of our own until the evidence becomes truly overwhelming. And yet the case for it being an interstellar impostor is intoxicating. That eccentricity of 1.1 is not just slightly hyperbolic, it's confidently so. While it may change, its starting point is highly suggestive. Gennadiy Borisov himself, a man who has demonstrated an almost supernatural knack for spotting these celestial needles in a haystack, clearly saw something unusual. His instincts flagged this object for a reason. Let us entertain the possibility. What if it is from beyond? Its profound faintness could be a clue, not a red herring. What if it is an object like ʻOumuamua, a rocky, non-active body, but one that happens to be following a more cometary trajectory? Its faintness would be natural if it isn't spewing a bright cloud of gas and dust. It might be a member of a third class of interstellar object. We have yet to confirm the interstellar asteroid, a silent, rocky bullet from a distant, shattered world. Or perhaps it belongs to a category so alien we lack the vocabulary to describe it. Every star system is a unique chemical and physical laboratory. The types of planets and smaller bodies that form depend entirely on the mass of the star, its chemical composition, its age, and its environment. 2i, Borisov taught us that with its carbon monoxide signature, what secrets might GB00810 carry? Is it composed of exotic ices that only sublimate much closer to the Sun, explaining its current faintness. Could it be a fragment from the mantle of a differentiated exoplanet, a piece of alien geology rich in heavy metals? Imagine the universe as a vast, interconnected ecosystem of stars. Each star is an island evolving its own unique forms of planetary life. For eons, these islands were isolated. Now we are beginning to see the flotsam and jetsam washing up on our shores. Oumuamua was a strange carved piece of driftwood of unknown origin. 2I. Borisov was like a coconut, something recognizably organic, but with a shell thicker and a chemistry different from our native varieties. What is GB00810? Is it just another piece of our own island's debris, misidentified in the surf? Or is it a message in a bottle made of a material we don't recognize, carrying a message we are not yet equipped to read? Answering this question requires our most powerful tools. The pursuit of GB00810 has become a race against time for astronomers. Large survey telescopes like the Catalina Sky Survey or the Zwicky Transient Facility swing into action, scanning the projected path of the object, hoping to capture more images to add those crucial data points that will shrink the error bars on its orbit. Once its position is locked down with greater certainty, the true giants can be called upon. Instruments like the Very Large Telescope in Chile or the Keck Observatory in Hawaii can perform the deep spectroscopy needed to decipher its chemical makeup. The Hubble Space Telescope, from its vantage point above the blurring effects of Earth's atmosphere, can provide the sharpest possible images, trying to resolve if there is any faint nascent coma developing as it draws nearer to the Sunday. Every photon of light collected from this distant smudge is a precious clue. This intense scrutiny is a testament to how profoundly our perspective has shifted. A decade ago, an object like GB00810 might have been dismissed, its ambiguous orbit logged and forgotten. But the confirmed discoveries of Oumuamua and 2I, Borisov, have opened the floodgates. We are now actively hunting for these interstellar nomads. We are primed to expect the unexpected. And the next generation of observatories will turn this new field of science from a trickle of discoveries into a deluge. The Vera C. Rubin Observatory, currently under construction in Chile, will survey the entire visible sky every few nights with unprecedented depth. It is predicted to discover not one or two, but dozens of interstellar objects every single year. We are standing on the threshold of a new era of galactic exploration, one where we don't have to go to the stars because the stars are coming to us piece by piece. And with this new capability comes a new ambition. The European Space Agency is developing a mission called the Comet Interceptor. It will be a spacecraft designed to park in a stable location in space and wait. It will lie dormant sometimes for years, until a suitable interstellar object, a pristine visitor on an achievable trajectory, is discovered. Then it will fire its engines and give chase to intercept the object and study it up close to taste its coma and photograph its nucleus. To read the message in the bottle directly, this is the grand context in which the mystery of GB00810 unfolds. It forces us to confront the largest questions of our existence. The discovery of these interstellar objects proves that our solar system is not an isolated oasis. We are connected to a vast galactic web. Planetary systems are not closed loops. They shed material, exchanging it across the interstellar medium. This has staggering implications. It breathes new life into the theory of panspermia, the idea that life itself, or at least its fundamental building blocks, could be transported between star systems, hitching a ride on an icy wanderer like 2I, Borisov, or sheltered deep within a rocky traveller like Oumuamua. Are we in fact the descendants of life that originated around another star? Could these interstellar visitors be the seeds of cosmic genesis? Whether GB00810 turns out to be a simple comet from the distant Oort Cloud, its interstellar credentials fading with each new observation, or whether its strange path is confirmed, marking it as the third great messenger from afar, its existence has already served a profound purpose. It has focused our attention once more on the silent, star-filled darkness. It reminds us that the sky is not a static backdrop. It is a dynamic living ocean with currents and tides and travelers on epic journeys. For now, GB00810 remains a ghost, a question mark painted on the cosmos. It is a testament to the patient work of a single observer staring into the abyss, searching for faint whispers against the stellar roar. It is a challenge to our technology, pushing our greatest observatories to their absolute limits to capture and decode its feeble light. And it is an invitation to our imagination, asking us to wonder what else is out there drifting in the cold and the dark between the suns, waiting for the improbable alignment of time and gravity that will bring it one day into our view. A faint comet or an interstellar impostor, perhaps the answer is less important than the question itself, which compels us always to look up and to wonder.